everyone. In this video, we're going to talk about Chapter 3, Special Parametric Families of Univariate Distributions in Theorem 11. I am Mary Christine Tanquilan, and let's get started. Theorem 11 states that let X have a negative binomial distribution, then we need to prove that our expected value of X is equal to RQ over P, our variance be equal to RQ over P squared, and our moment generating function be equal to quantity R, P all over 1 minus Q e to the t. Let's first prove our moment generating function. So by definition of negative binomial distribution, we have m sub x to the t is equal to summation of negative r taken x times p to the r times negative q e to the t to the x equal to as rx equal to 0 to infinity. So this will be equal to p to the r summation of negative r taken x times negative q e to the t, the x, as our x equal to 0 to infinity. So by equation 33 in Appendix A, we have p to the r times the quantity of negative r 1 minus q e to the t. So this will be equal to p to the r all over 1 minus q e to the t r. After proving our moment generating function, we then prove our expected value of x. So let's get the first derivative proving our moment generating function. We then prove our expected value of x. So let's get the first derivative of m sub x to the t first. So equals quantity r m sub x to the p all over 1 minus q e to the equals. So this will also be equal to r p to the r p all over 1 minus q e to the t minus q e to the t. So this will also be equal to p to the r. So by 1 quotient minus q e to the t, we then have, so by quotient minus q e to the t, we then have times 0 minus p to the r 1 minus q e to the negative q e to the t times 0 times minus p to the r times the negative q e to the t of r minus 1 times 1 minus r q e to times the quantity of all over our denominator squared 1 minus q e to the t all over our denominator squared. This will be equal to negative p to the r times negative q e to the t times r times negative p to the r of r minus 1 negative q e to the t 1 minus q e to the t times r times the quantity all over r minus 1 1 minus q e to the denominator squared, our denominator q e to the t denominator squared, our denominator. Next, we then multiply our negative p to the r, our negative q e to the t, and then multiply. So this will be our negative p to the r, our negative q e to the t, and r. So this will be equal to of r minus 1 r p to the r minus q e to the t all over our denominator times the quantity of r minus 1 1 minus q e to the t all over our denominator. So by law of exponents, this will be equal to So by law of
r
exponents,
p to the r,
this will be
q
equal
e to the
to
t,
all over
r p
1
to the r,
minus q
q e to the
e to the
t,
t all over
r plus 1.
1 minus q e to the t. This will also be equal to over
r plus
r
1.
p to the r q e to the t. This will also be equal to
Times the quantity of r plus 1,
r p to the
1
r
minus
q e to the t.
Times the quantity of
We
r
then let
plus
our
1,
t be equal to
1
0 to
minus
get
q
our
e to
expected
the t.
value of x. So we then let our t be equal to 0 to get our expected value of x. So copy our first derivative. This can also be written as this. Copy our first derivative. This can also be written as this. So let our t be equal to 0. So we will now have, so let our t be equal to 0. So we will now have, this will be equal to negative q. This will also be equal to negative q 1 minus q. So this will also be equal to 1 minus q. So let's write negative r minus 1 times negative q. Negative r minus 1 multiply times negative q. This will be equal to multiply p to the r. This will be equal times rq times 1 minus p to the r minus 1. So this will also be equal to rq p because times
Recall
1 minus q negative r minus 1. So this
P
will
is
also
equal
be
to
equal
1
to
minus q.
p because so
Recall
p
that
to the r
p is
times
equal to 1 minus
rq
q.
all over
So
p to the r
p
times
power
rq
of r plus 1
all over. So by
p
law of exponents,
power of
we
r
have
plus 1.
our expected value of x.
So by
Equal to
law of
r
exponents
over we have our expected value of x equal to r cubed.
we have proven our moment ranging function and our mean already. So we have proven our moment ranging function and our
let's get the
mean
second
already.
derivative
So
of our moment ranging
let's
function.
prove
So
our
copy
variance.
the
So
first derivative. Let's get the second derivative of our moment ranging function. So copy the first derivative. So this will also be equal to p to the r times r cubed times e to the t. So this will also be equal to times 1 minus
p to the
q
r
e to the times r cubed
the
times
power
e
of
to the
negative
t
r minus 1
times 1 minus
multiply
q e to the t r cubed p to the
the
r
power of negative r
times
minus
e to
1
the t
times the
multiply
quantity of negative r minus 1
r
1
cubed p
minus
to
q
the
e
r
to the t
times e to the t
times the quantity of negative r minus
so
1 1 minus q e to the t.
we have r cubed p to the r times e to the t.
So
times 1 minus to the t.
we have negative 1. So
r
our
cubed p to the r
reciprocal
times e to the t times 1 minus to the t
power
r cubed p to the
negative
r.
1. So our reciprocal would be
E to the t
minus
r cubed p to the r plus 1
times the quantity
e to the
of
t
negative r minus
minus
1
r
minus q
plus
e
1
to the t times the quantity of negative
times
r
negative
minus 2
q
plus 1 minus q e
e
to the t
times quantity
times
negative r
negative
minus
q
1
1 minus
plus
q e to the
e
t
to the t times
quantity
evaluate.
negative r minus
So we
1
then
1
now have
minus
our
q
second
e to the
derivative
t
r cubed p to the r
evaluate
times, so we then now have
2
our
to the t
second derivative, r cubed p
e
to the
power
r
of 2t
times
e
q to the t times r plus 1
e to the power of 2t
times r times
q
negative times r plus 1 r minus 2
1 minus
times
q
r
e.
to the t plus
Negative
1 minus q e to the t r minus 2
negative
1
r
minus
minus
q
1.
e to the t
So this
plus
will be our
1
second
minus q e
derivative,
to the t.
negative r minus 1.
So this will be,
To get our variance,
let t be equal to 0 to get our variance. So we let our second derivative be equal to 0. So this will be equal to r cubed p to the r times e to the 2t times q times r plus 1 times 1 minus q e to the t all to the power of negative r minus 2 plus 1 minus q e to the t to the power of negative r plus 1. So let rt be equal to 0. This will now be equal to r cubed p to the r times e to the power of 2 times 0 times q times r plus 1 times 1 minus q e to the 0 to the power of negative r minus 2 plus 1 minus q e to the 0 to the power of negative r minus 1. So this will now be equal to r cubed p to the r times q times r plus 1 times 1 minus q to the power of negative r minus 2 plus 1 minus q to the power of negative r minus 1. So, by the definition of our variance, this will be equal to r cubed p to the r times q times r plus 1 times 1 minus q to the power of negative r minus 2 plus 1 minus q to the power of negative r minus 1 minus our mean squared. So r q of all over p to the power of 2. So this will be equal to r q to the power of p squared.